Today we're on pages 194 and 195 of our textbook. You need your calculator. More work with quadratic equations. We have seen that some quadratics are factorable and some are not. We also know that certain methods can always be used to solve a quadratic. What are these methods? Quadratic formula can always be used. And complete the square can always be used. As long as with completing the square, the a value must equal 1, right? If it's not, if it's 3, you can just divide every single term by 3. Let's say you use the quadratic formula to solve a quadratic. How can you tell from your answers when you could have factored the quadratic? Well, if your answers are rational, then you could have factored the quadratic. And remember, what is a rational number? A rational number is any number that can be expressed in the form of a fraction where your numerator and denominator are integers. So decide if each set of numbers is rational. So rational, things that are rational are 2, 5/4, -3. 1.5 is rational because it can be expressed as 3/2. So any terminating decimal or integer or fraction is rational. What's irrational is the square root of 2, the square root of 17/3. You know, if you have a square root that cannot be simplified, that's not a perfect square, then that's an irrational number. And non-real is when we have a negative underneath the square root. Okay, so decide if each set of numbers is rational, irrational, or non-real. So 3 plus the square root of 7 all over 2, and 3 minus the square root of 7 all over 2. Since the square root of 7 is irrational, then this whole set is irrational. The next one, 3 plus the square root of 25 over 2, 3 minus. Yeah, this is rational because the square root of 25 is 5. So this is the same as 3 plus 5 over 2, 3 minus 5 over 2, which is going to produce rational results. Three plus the square root of 0, all divided by 2, 3 minus, yes, because the square root of 0 is 0. So this is rational. Three plus or minus the square root of -9. The square root of -9, because it's negative, is non-real. When do we usually see numbers in this form? When we use the quadratic formula. What part of each number dictates what type of number it is? It's whatever is underneath the square root. The part under the square root symbol. In the quadratic formula, b squared minus 4ac is the expression in the radical. It's known as the discriminant because it helps you discriminate or differentiate between quadratics that can be factored and those that cannot be factored. Use the discriminant b squared minus 4ac to quickly determine if each of the following quadratics can be factored. Indicate if the quadratic has non-real solutions. So it's factorable if this b squared minus 4ac is a perfect square or 0. So again, we're only using b squared minus 4ac. Write the formula, b squared minus 4ac, so negative 3 squared minus 4 times 2 times 4. That's 12 minus 32. Or again, you can use your calculator. Not 12, that's 9. Glad I caught that. 9 minus 32, which is negative 23. This would be non-real. Looking at the b squared minus 4ac piece, b is negative 7, squared is 49, minus 4 times 3 times negative 6. Again, if you need the calculator, that's fine. I've got negative 12 times negative 6 is positive 72. So I've got 49 plus 72, which is 121. That's a perfect square, right? Since this is a perfect square, so this would be factorable. Let's put this in standard form, so subtract 5x, x squared minus 5x, minus 2 equals 0. So a is 1, b is negative 5, and c is negative 2. Negative 5 squared is 25, minus 4 times 1 times negative 2, that's 25. 25 plus 8 is 33. Again, you're thinking, well, that would be the square root of 33, right? Under the radical. So this is irrational, so it is not factorable. The same with D, put it in standard form first. Add 9 to both sides. So A is 1, B is negative 6, and C is 9. Negative 6 squared is 36. Minus 4 times 1 times 9 is also 36 minus 36 is 0. And it's factorable if b squared minus 4ac is a perfect square or is 0. So this would be factorable. Which of the following sets represents the x-intercepts? Well, x-intercepts, whenever you're looking at an x-intercept, that means the y value is 0. So replace y with 0. And let's solve this. My preference is always try to factor first. Alright, so I'm going to try to see, is this factorable? I'll use the rainbow. 3 times 6 is 18, positive 18, factors of positive 18 that sum to negative 19 are negative 18 and negative 1. So I'm going to solve this by factoring it. 3x squared minus 18x minus 1x plus 6 split, bring down the operator. GCF here is 3x, x minus 6, and 1, x minus 6. So x minus 6 is one factor, 3x minus 1 is the other. Back to our equation, equals 0. Set each factor equal to 0, so x equals 6. Adding 1, dividing by 3, x equals 1/3. Choice 4. Number 4, consider the quadratic function f of x equals x squared minus 4x minus 36. Algebraically determine the function's x-intercepts using the quadratic formula. Okay, using the quadratic formula, it tells us, so we'll use it. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And a is 1, b is negative 4, and c is negative 36. Okay, so negative 4, 1, negative 36. We switch. So negative 4 is positive 4, plus or minus the square root of 16. That's going to be plus. I don't know what 4 times 36 is. Alright, so here I'll just put it in the calculator. Negative 4 squared minus 4 times 1 times negative 36. It's 160. All divided by 2. Express your answers in simplest radical form. Okay, so I'm going to split this up. So x is going to equal 4 over 2 plus or minus. Now, the square root of 160, I'm not sure how to simplify 160. I know 16 times 10. Oh, actually, that's it. 16 times 10, right? Because the other factors of 10 are 2 and 5. Yeah, so that's it, 16 times 10. And the square root of 16 is 4. So that would be 4 square root of 10 all over 2. So we get x equals 2 plus or minus 4 divided by 2 is 2. 2 plus or minus 2 square root of 10. Express the x-intercepts of the quadratic to the nearest hundredth. Alright, go to the calculator. 2 plus 2 square root of 10 to the nearest hundred. The 2 is in the hundreds place. That would be 8.32. And arrow up, grab that. Change the plus to minus. Negative 4.32. Using a calculator, sketch a graph of the quadratic on the axis given. Use the intercept command to verify our answers. Remember to put y to, oh, okay. So this here is, well, let me put it in. So y equals x squared minus 4x minus 36. And let me adjust the window before I press graph to what is shown here. So window, x is going from negative 20 to positive 20. And the y min is negative 50. And the max is positive 50. And I'll press graph. So we want to sketch this graph. Again, it's just going to be a sketch, so let me move this down a little. close enough. Alright, so we're going to use the intersect command. Oh, intersect command. Alright, so I know on another video when we looked for zeros, or x-intercept, we did second, trace, 0. Right? And then we have to ask for a left bound and a right bound. Well, a way around that is to go back to y equals, and in y2 put 0, right? Because that's what, when we solved this, we replaced y with 0, or f of x with 0. I actually didn't show that above, but that's what we did. Okay, so if you do that, now we can just do second trace number 5, intersect command, which I think is just a little easier. And that, okay, so now it asks for the first curve, so we press enter. It jumps to the second curve, our red line, y equals 0. We press enter. For the guess, we press enter. So it gives us the coordinates of this point, the point on the left, so the x-intercept to the left of our y-axis. And let's just write down the coordinates. This is negative 4.3245555, comma 0. So this is a means of checking. And now second trace, number 5 again. First curve, you just press enter. Second curve, enter. But for the guess, you have to move the cursor closer to the other point. Otherwise, it's just going to give you the point it just found. So this is 8.3, 8.3245553, comma 0. Label the zeros on their graphs. In other words, I label them with their points. Alright, we're going to skip number 5 because we're already 17 minutes into the video. So let's look at number 6. Find the intersection points of the linear quadratic system shown below algebraically. Then use your calculator to help produce a sketch of the system. Label the intersection points you found on the graph. Alright, so remember, intersection points. Okay, so the two graphs would intersect when they are equal to each other. So algebraically, we're solving first. So we take our 4x squared minus 6x plus 2 and set it equal to 6x minus 3. 4x squared minus 6x plus 2 equals 6x minus 3. Let's put this in standard form. So we'll subtract 6x from both sides and add 3 to both sides. I'll show it here. Again, I usually do not. And we have 4x squared minus 12x plus 5 equals 0. I'm going to, again, my preference is if it's factorable, I would choose to factor instead of using the quadratic formula. So the leading coefficient is greater than 1. We'll take the rainbow. 4 times 5 is 20. Are there factors of 20 that add to negative 12? Yeah, negative 10 and negative 2. Okay, so let's rewrite this as 4x squared minus 2x minus 10x plus 5. 4 terms now, we group, splitting. 2x is a GCF here, 2x minus 1. Again, you should be able to do this on your own. And then here, taking out 5. So we have 2x minus 1 times 2x minus 5 as factors. Again, bring down the equals 0, go back to solving our equation, set each factor equal to 0, or you can go right to the answer. You know, many of you can go right to add 1, divide by 2, x equals a half. have 5 divided by 2, x equals 5/2. Okay, those are only the x values. When x is 1/2, what is y? Go back to the linear, it's just the easier one, it's less complicated. When x is 1/2, y equals 6 times 1/2 minus 3. 1/2 of 6 is 3, minus 3 is 0. So we have the ordered pair 1/2, comma, 0. And when x is 5/2, y equals 6 times 5/2 is 15, minus 3 is 12. So we have the ordered pair 5/2, 12. So these are our solutions. 1/2, 0, they are our intersection points, and 5/2, 12. Okay, now we're going to use our calculator to help sketch the system. Alright, yeah, I don't like that we're going, our time here is over 21 minutes already. Okay, but quickly, so 4x squared minus 6x plus 2, and then 6x minus 3. Change the window to what's here, which is negative 5 to 5 for the x, and negative 5 to 15 for the y, and let's do a quick graph. I'm just going to do my best at kind of eyeballing this. If I wasn't so rushed, I'd have a much nicer graph. Alright, and then just quickly second trace number 5. Enter, enter, enter. There we have 0.50. It's supposed to be here. And second trace number 5 again. Enter, enter. Move your cursor. 2.512. And just make sure you label each graph with its equation. Y equals 4x squared minus 6x plus 2, and y equals 6x minus 2. All right, thank you very much for your attention.